A uniform rod of mass small m is bent into a form of a semicircle of radius r. Right. Now, basically what is happening, there is a uniform rod. There was initially a uniform rod which is bent in the form of a semicircle, right? This is a semicircle basically, and this is the point O, and this is the point A. This diagram was basically given in the question, right? What is the moment of inertia of the rod about an axis passing through A and perpendicular to the plane of the paper? So we have to calculate the moment of inertia about this point, right? Now, this question might seem a little difficult to most of the students, but a student who knows the concept will be, comfortable with this question. Now let us see how to solve this question. We know that since this has a mass m and radius r, this is a part of circle, right? Now for ring type of structures, we have IO, which is the center of the circle, is equals to mr square. Now since this is a part of the circle, so that means its moment of inertia will also remain the same about O, right? Which is mr square, right? It will remain the same, where m is the now, which is the mass, which will be small m into r square, right? IO is given to us, which we know, right? Now, we know that if we have to calculate IA, moment of inertia, this is basically parallel axis theorem. What we will be doing is we have to use what? Parallel axis theorem, right? Now IO is what? IO is the moment of inertia about O and perpendicular to the plane, right? We have to calculate moment of inertia of A about the about perpendicular to the plane. Most of the students will make the mistake and write the equation as IA will be equal to I naught plus mr square, right? Which is absolutely wrong, right? This is not the correct equation, because what parallel axis theorem says is that moment of inertia about any point is given by moment of inertia about the center of mass plus mx square, where x is the distance between the axis and the center of mass, right? So here we need the I center of mass, but I naught now is not the center of mass. It was in case of circle, right? When it was a ring, but in case of a semicircle, I naught is not the center of mass. From center of mass chapter, you might be knowing that center of mass is at a distance. If this is basically the center of mass, this is IO. So this distance is basically given by 2r by pi, right? This distance is 2r by pi, right? So basically, if I know I naught, I do not know ICM. So first of all, for calculating IA, I have to calculate ICM, right? Now how do I calculate ICM? I only know that I naught is small mr square. So what I do, I know this distance. From the same parallel axis theorem, I can say that I naught will be equal to ICM plus small m into 2r by pi whole square, right? Because this is the minimum distance between them. So I naught I know. So that means I can get ICM. ICM will be equal to I naught minus m into 2r by pi whole square, right? This is basically one equation. So I get ICM from this funda, right? I got ICM. Now I need IA, and for IA I also require the X. Is that right? I require the X. What is the distance between the center of mass and the point A, if this is the point A, right? Now I know that this distance is R, so I can complete this triangle, and this is 2r by pi, this is R. If this is X, so that means from this triangle I can know that X is the hypotenuse, which will be equal to under root of 2r by pi whole square plus r square. Is that correct? Right. So I'll put these two things. This is the first thing, and this is basically the second thing. I'll put these two things into this formula. So IA will be given by I naught minus m into 2r by pi whole square plus mx square, small m x square, where x square will be what? 2r by pi whole square plus r square, right? So what will happen? This is minus, this is plus, so these two will cancel out. So what I'll get is I naught plus mr square, and what is I naught? It is also mr square, so that means IA will be equal to 2mr square. So basically this is the answer. Now this was a very good question which included a lot of concepts. Concept of center of mass, concept of parallel axis theorem. If you have understood this question, parallel axis theorem, this is all which can be, this is the maximum thing that can be asked from the parallel access theorem. All your concepts, all your queries related to parallel access theorem will be complete using this concept, right? So this was a very good question in fact.